The first portion of our demo demonstrates Snell's Law, which states that N1 sine of theta 1 is equal to N2 sine of theta 2, where theta 1 is the incident angle and N1 is the incident medium. The resulting angle occurs because when light enters a separate medium, its speed changes. The next part of our demo demonstrates total internal reflection, which only occurs if two conditions are met. The first condition is that the light goes from a higher index of refraction to a lower index of refraction. So oil has a higher index of refraction than water. The second condition is that the incident angle is greater than the critical angle, where the critical angle is when the angle of refraction is 90 degrees. This is why this only happens at a specific angle and only when the laser is shined through the oil first. As you can see that past a certain angle, the laser beam goes back into the water. Lastly, we have a demonstration of fluorescence, which is caused by the excitation of atoms in a material from incident radiation, which then re-emit almost immediately. The violet laser attenuates most likely due to absorption and emission in the infrared. The laser becomes more blue, probably because the laser contains multiple wavelengths of light, where some are being absorbed more than others, which results in a change in color. This is a consequence of fluorescence. The red laser does not fluoresce in the oil because it is a lower energy of light and does not excite the electrons of the molecules in the oil. Lastly, we demonstrated the difference between how the laser beams look when shined through the water compared to how they look when shined through the oil. You can see that the blue laser does not make it all the way through. Lastly, we demonstrated the difference between how when we shine the laser beams through the water, they make it all the way through and shine onto the wall. However, when we shine them through the oil, the green and red lasers do make it all the way through and hit the wall, but the blue laser does not because of the fluorescence previously mentioned.